So here we're going to continue on Unit 2. So write Unit 2, Lesson 8. And here we are going to continue on the acid, organic acids. Organic acid. So organic acids have the function, the group function that we call carboxyl group. So what is the carboxyl group? It is this one. Carbon with oxygen and with the OH bond. This is what we call carboxyl group. Carboxyl group. So example of acid, all molecule that has this carboxyl, it is an acid. For example, examples. I can have, for example, this one, HCOOH. This one, it is methanoic acid. Methanoic. We're going to know how we name them. This is methanoic acid. I can have another one, CH3, C, this one, OH. This one is an acid. Why? Because it has the carboxyl group. So what we call this one, because I have two, it will be ethanoic acid. Ethanoic acid, etc. So now nomenclature or naming acids. Naming carboxylic acids. Carboxylic acids. They are weak acids. They are acids. They are weak. So, for example, I want to name this one CH3, CH, CH3, CH2, C. I have carboxyl group OH. So I'm going to name them the same as we did always. I have first to look as the biggest, the parent chain. Which one? 1, 2, 3, 4. 4, what does it mean? Butane. And because it is an acid, the E here, which we change it to wick. So we change E to wick. Like this one here. So now it will be butanoic acid. Butanoic acid. Butanoic acid. Now it will be butanoic acid. But wait a moment, we have ramification, we have side chain here. So I'm going to put this chain in the name. We have to label or number our carbons. So what is the first one? We have the function always has the priority. So this one will be carbon 1, carbon 2, carbon 3, carbon 4. And this chain, it is in third. So I'm going to write it now 3 methyl butanoic acid. Butanoic acid. This is the name it will be. We're going to take another example now. Say I have another one. I have this function here. COH, and I have here CH2, 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 C, like this one, OH. So how many carbons I have? 1, 2, 3, 4, 5, 6. So it will be hexanoate. It will be hexane. If it wasn't the acidity, it will be hexane. But as we said E must be changed to wick because it is an acid. It will be wick, hexanoic, hexanoic. Like that. But wait a moment, we have two groups. One here and one here. So because there are two, it's like what we are going to do. We are going to add D. Duic. I'm going to put it here D. Because there are two. So the complete name now, it will be hexanduic. Hexanduic. So if I have two groups, it will be D. If I have three groups, it will be 3, etc. Okay, so the naming, as I said, the same as the naming that we did before. So I'm not going to go lengthy on that. Only you have to change the E by awake, and that's it. Otherwise, look at the videos before, especially what we did with the alkanes. It is there when we alkane. Alkene, yeah. Okay. Other things that we are going to see, yeah, other representation. In chemistry, when you have organic molecule, we don't represent the carbons and the hydrogens. For example, I have this molecule here. For example, I have COOH, and I have carbon CH2, 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 for example, CH2, C, I have an O here and OH. So we don't represent the carbons and the hydrogens like the cyclic. You remember the cyclics? We said this one, for example, it is, for example, this one, it is a yeah, alkane, hexane. This one, pentane, for example, but we don't represent the carbons. The same here. What we are going to do, we are not going to but we're going to represent them by what? By angles. For example, this carbon, we're going to do it because it is the function. It has the function. We're going to put it. The one that has the function, we're going to put it. But this one has not the function. So what we are going to do, we're going to do it like that, with an angle. I have the this one, it is here, and this one here, I'm going to put it like that. How many carbons I have? I have 1, 2, 3, 4, 5, 6. So this one, 1, 2, 3, 4, 5, and the 6 has the function, so I'm going to put it OH. And when I see here, I know it is a carbon with the hydrogens that I have, the necessary hydrogens. How many hydrogens I need here? I need 2. So this is the representation. I'm going to give another example for this representation that we call it skeleton representation. This representation, we call it skeleton. Skeleton. Yeah, but okay, skeletal representation formula. Skeletal formula. We are representing only skeleton. This is what we represent. For the acid, I have to finish all with the acid. Properties of the acid. Properties of carboxylic acid. These acids are weak acids. What does it mean? Does it mean it doesn't dissolve completely in water? Weak acids don't dissolve completely in water. Don't dissolve completely in water. Weak acid, completely with acid. It became weaker and weaker with the size. Okay, weaker and weaker with the rise of the size of the acid, with the rise of the size of the acid. What does it mean? For example, if I have this acid here, ethanoic, for example, this one, OH, and I have here H3. This one, it is stronger than this one, for example, when I have 3 carbons. Why? Because this one here, it is bigger than the other one. Yeah, so this one is weaker than this one. This one is stronger than this one. So ethanoic acid is stronger, but they are all weak. They don't dissolve completely. Stronger than propanoic. Propanoic acid. Okay, this is said. What are the reactions? What are the reactions? What we can do? How they react? So with the acids, we have two reactions: neutralization. So I'm going to write reactions of carboxylic acid. Carboxylic acids. First, neutralization. And neutralization, it is like any acid. Neutralization. Like any acid plus base will give you salt plus water. This one you know it from grade 9 and grade 10. Example, for example, say I have CH3 ethanoic acid, vinegar. I have O and I have OH, plus, for example, in a sodium hydroxide, OH. So what will give me? Yeah, this acid, what will do? This one will lose this H, that will go with this OH. It is double displacement. Okay, you know that. And this one will come here. So what we're going to have? CH3, CO, O, Na plus H2O. So the mechanism I'm going to show to you again, because it is double displacement. I have an H here, and because it is an acid, it will lose this H. This one, what we have here, we have Na plus. To do it with another. This one here, it is Na plus and OH minus, and this one here will be what? CH3, CO, O minus, H plus. Because this one, this bonding will be broken, and what we'll have double displacement. This one will go with this one. We did it in grade 10, and this H will go with this H will go with OH. So what we'll get in the end, we're going to get CH3, CO, and this O will get with the Na, so O Na plus, and we'll get H2O. Okay, if I want to write it now in a compact formula, so this is the mechanism. So I'm going to raise it now here. I explain how we get there, how we get here. So this one, usually we write it CH3, COOH. This is how we write them. Plus NaOH. It will give you CH3, COONA plus H2O. This is and this is salt, and this is water. Okay. So this one it will be aqueous liquid. The other reactions that we can do with acid is esterification. So neutralization, you have to know the neutralization. Always an acid plus base will give me as salt and water. What happened now? What we call it esterification. Esterification, also it is a double displacement reaction, but this one it will be between an acid plus alcohol. Alcohol will give me an ester plus water. The mechanism, it is same as neutralization, but it is not a neutralization. It is the same as. I'm going to take an example. For example, I'm going to take an example, and we're going to see. Say I have an alcohol. Alcohol, what is it? CH3, for example, OH. Remember, an alcohol has a group of OH with an alkyl chain, CH3, OH. Plus an acid. an acid. For example, I'm going to take the same CH3, C, I have O and OH. Look, this one here, it is not an alcohol. Why? Because it has this carbonyl, the O. This one, no, it doesn't have an O. That's why it is an alcohol. This one is an acid. Okay? Because of this O and this OH, they are an acid. And this one, it is an alcohol. Okay. So what they will give me here? Look what will happen. So this CH3OH, I'm going to write them like this one, CH3OH. And I have CH3 here, CO, and I will have the OH here. But this bound in here, it will be broken. I will have H plus. This one will be broken because it is double displacement. What I will have here, this is minus and this is plus because it is an acid. This OH will be broken. This one, it is an alcohol. This one will be broken. This one will be plus. This one will be minus. And what will happen again? Double displacement. This H plus will go with the minus, with negative here. And this negative here will go with this positive here. It is the double displacement. So what I will get in the end, I'm going to write this one with another color. This one here will be CH3, CO. The O minus will be bound with CH3 plus, and the OH minus will be bound with H plus. It will be H2O. And this is what I'm going to go to. And this one, it is an ester. It is double displacement again. In alcohol, this one will be broken. And in the acid, this OH will be broken. Not this O. It is this H here. This H will be broken. And we have double displacement. So what will give me? It will give me CH3, CO, O, CH3 plus H2O. This one, it is an ester. In the next video, you're going to know to see the esters. This one, it is not salts, but ester, an ester. And this one, it is what? This one, it is alcohol. And this one, it is a carboxyl, or it is organic acid. This is an organic acid. Organic acid. Okay. Yeah, I think we are done. Esterification, for example, we have this one here. That's it. I'm going to stop on the acids. Good. Bye.